So in this particular session, what we'll be covering is partial correlation coefficient. Okay, so we'll be doing an example of that. So today what we are covering from is we've been using Kriti publications statistical methods. Could be valid for MBA, MBS, BBA, whatever you're studying. Okay, so what we've been given is that we've been already the correlation has already been calculated. We just need to calculate the this thing, partial correlation. Okay, so R12 is 0.8, R13 is 0.5, R23 is 0.9, right? So we know that R12.3, which means that 2 is the independent variable, 1 is the dependent variable, third is the other variables are constant. Okay, that's it. That is partial correlation, right? So where the other variables are kept constant and the effect of independent variable on dependent variable is measured, right? So we will look at that first of all. So what we've been given is that we've been given the correlations already. So the formula is R12 minus R13 dot R23. Okay, see the pattern over here. So R12 is at the beginning, right? So we write R12 and then minus R13 and then 23. Okay, before the dots we multiply it together, and then after that 1 minus R13 square dot 1 minus R23 square. Okay, just these numbers square. Okay, so solving for it, what we will get is 0.8 minus 0.5 into 0.9. So under root 1 minus 0.5 square times 1 minus 0.9 square, right? So when you calculate it, let's see what we'll get. Okay. So you could use bracket as well. You could do it in one go, okay? Because you are not going to get marks for elongating it too long. So we just try to compute it in one go, okay? 0.8 minus 0.5 into 0.9, and then we divide it by under root 1 minus 0.5 square. All right, and then again divided by which this figure, right? So 1 minus 0.9 square. Okay, so the value that we get is 0.927. Okay, is equals to 0.927. Okay, so now if you're solving for something else, let's say R13.2. Okay, let's look at that as well. R13.2, right? So your formula is R13 minus R12.23, right? R23. 3 2 2 you can write it in anyways because it is symmetric. We learned that earlier on. Under root 1 minus R12 square, 1 minus R23 square. So putting the values in, this is 0.5, I guess, minus 0.8 into 0.9, right? And then 1 minus 0.8 square, 1 minus 0.9 square, right? So when we compute it, how much will we get? 0.5 minus 0.8 into 0.9 divided by 1 minus 0.8 square, right? So 1 minus 0.8 square, right? And then again divided by 0.9, right? 1 minus under root 1 minus 0.9 square, right? Okay, so how much do we get? Minus 8.11, minus 8.4, okay, 0.84. Okay, so now if you're computing it for, let's say, 23.1, okay, let's see what happens. So if we are solving it for R23.1, what we will do is that R23 minus R12.R 1, 3, okay? You can write 3, 1, 2, 1, doesn't really matter because it is symmetric, right? So under root 1 minus r12 squared, 1 minus r13 squared. So what will be a 2, 3? It will be 0.9 minus 0. What was this? 8 times 0.5, right? 0.5, 0.8, right? So 1 minus 0.8 square, 0.8 square, 1 minus 0.5 square. So how much will we get? Let's compute it. 0.9 minus 0.8 into 0.5, and then we divide it by under root 1 minus 0.8 square, right? 0.8 square. So again divide it by under root 1 minus 0.5 square. Okay, there has been 2 roots. I made a mistake. So 1 minus 0.5 square. 0.96, okay? 0.96. So that's our partial correlation coefficient, okay? So the correlation between 3 and 2 was 0.96, and then the correlation between this one, keeping 2 as a constant, 3 on 1 was minus 0.84, okay? So it was a negative correlation, okay? In between third, right? Okay. So if let's look at the answer as well. Let's tally it quickly. 10 number, right? 10 number. 0.84, yep. Everything is all good, okay? So yeah, basically if there are 2 negative variables, then there will be 1 positive, and then basically there will be 2 positive, then there will be 1 negative, okay? So it just depends how much the correlation is between these variables, okay? So if you have any confusions until now, if you have not understood this particular question, please do comment down below. I'll definitely be happy to answer it for you. If you have any other questions regarding correlation and regression analysis, please do feel free to comment it down below and definitely solve it and send it to you as well. You can send it on my email as well, it does not really matter. So until next time, bye bye.